The synthesis, characterization, and evaluation of cellulose graph poly 2-diethylamino ethyl methacrylate for heavy metal removal from wastewater is reported. Cellulose was obtained from a corn cob biomass using a recently developed gas phase acid pretreatment process, PAP. The obtained corn cob cellulose, CCC, was functionalized by partial esterification of the superficial OH groups with alpha-bromoisobutyryl bromide, BIB, under mild conditions, room temperature, and dimethylformamide, DMF as solvent. The functionalized cellulose was characterized by Fourier transform infrared spectroscopy, FTIR, scanning electron microscopy, SEM/energy dispersive spectroscopy, EDS, thermogravimetric analysis, TGA, and X-ray photoelectron spectroscopy, XPS. Chemical compositions of the material surfaces were analyzed by XPS. The depth of penetration associated with this technique is a few nanometers. XPS spectra for cellulose, before and after esterification, are shown in Figure 1. According to the literature, unmodified cellulose exhibits 2 peaks in the complete XPS spectra, oxygen and carbon around 532 and 285 eV, respectively. XPS spectra for C1s is shown in Figure 2 for the corn cob cellulose sample. The 5 peaks at 285.50, 286.71, 288.10, 286.71, 286.79 eV that result from the deconvolution of C1s can be assigned to CHCH, CHO, CHOH, CH, CH2, and CH2, OH, respectively. New peaks between 20 and 240 eV corresponding to BR appeared in the modified cellulose samples, which indicates that ATRP initiator was attached onto the surface of cellulose. The appearance of new signals at 258.8, 184.6, 71.1, and 28.4 eV, corresponding to BR3S, BR3SP, BR3D5, BR4S, respectively, is observed in the complete spectrum. Furthermore, the signals corresponding to O and C are slightly shifted at 535.4 and 286.7 eV. The C1 spectra for MCC after esterification is shown in Figure 2, where it is possible to observe the appearance of a signal at 289.36 eV, which corresponds to C equals O and 285.58 eV for CBR, respectively. The appearance of these peaks indicates the correct modification of cellulose. On the other hand, the band corresponding to the carboxyl group that belongs to the bromoisobutyryl group was found using infrared at 1750 cm. 1. The BIP functionalized corn cob cellulose was used as initiator for surface-initiated atom transfer radical polymerization, 8-ERP, of 2-diethylamino ethyl methacrylate. Grafting of the polymer onto cellulose was confirmed by FTIR, TGA, and XPS. The performance of the cellulose copolymers for the removal of lead and iron from water was evaluated. Removal percentages of 90% in 90 minutes for lead was obtained with CCC, G, P2-diethylamino ethyl methacrylate.